All right, so the next learning target 5 is the next way we're going to learn how to solve equations that are in quadratics. That means that they're going to have an x squared term, and in this case, they're not going to be able to be solved just by taking the square root, like in the last examples that we saw. And this is because we're going to have equations where we have a term with an x squared, and we're going to have a term with an x. Okay, and so we're not going to be able to combine those together in any way, and we're not going to be able to solve it just by taking the square root like we were in the last problem. Okay, so this is going to be using something called factoring. Instead of just taking the square roots, we're going to be taking the equation and manipulating it into something that we can solve. Okay, and it's going to use these 3 different definitions here, and I want you to go ahead and just write them down. I'm going to go ahead and just not talk through them yet, but I want you to pause the video right now and then press play once you've gotten it all written down. Okay, now that you've got those written down, expanded form means that it's written without parentheses, and all like terms are combined. That means everything is expanded out as much as it can be. We've done the distributive property, gotten rid of those parentheses, we've expanded it out as far as we can. Okay? Factored form means that it's written as the product of 2 or more expressions. Okay? Factor, remember in the simplest terms, if I ask you to factor a number, I mean to tell me the numbers that multiply to that number. So factored form is going to look like the product or the multiplication of 2 expressions or more. Okay? And then once we've got it from expanded form to factored form, which is what we're going to work on, we can use the zero product property, which states that if I take 2 factors and multiply them, and the answer is 0, then either x equals 0 or y equals 0, or both equal 0. Both x and y equal 0. One or more of the factors that multiply with an answer of 0 have to equal 0. Okay? So we're going to use that fact to solve these 2 equations. These equations, A and B, are already given in factored form. That's because I can see that there's 2 expressions multiplied together to equal 0. In this case, 3 expressions multiplied together to equal 0. That's what factored form is. And so we know that either x minus 9 equals 0, or 3x plus 4 equals 0, or both equal 0, right? Because these 2 multiplied have a product of 0. So that means x either equals 9 by solving this equation, or by solving this equation, subtract 4, I get 3x equals negative 4, divide by 3, and I get that x equals negative 4/3, or negative 1 1/3. Okay? If I look at this third one, I've got 3 products, so I want 3 expressions multiplied, so I want to think about each of those parts, each of those factors being equal to 0. So in this case, 4x equals 0, divide by 4, that just means x is 0. Here, x plus 6 equals 0 means that x equals negative 6. 4x plus 9, I'm going to subtract 9, I get 4x equals negative 9. I'm going to divide by 4, and I get that x equals negative 9/4, or negative 2 1/4. So when I'm circling, depending on how many factors I had to start with is going to be how many answers I have. So I had 3 factors in this one, I have 3 answers. I had 2 factors in the first one, which means I have 2 answers. Okay? So now we need to factor. So this is something that we're going to use often, and it's something that it's going to take practice. Okay? It's kind of like figuring out a Sudoku puzzle. You're going to have to do a little bit of guess and check, and you're going to have to use a little bit of your reasoning skills to figure out what the factors are that equal that expanded form. Okay? So you see that there's no parentheses in these. These are given in expanded form. And we're going to use y equal to 0, remembering back to our very, very first time that we solved equations. with quadratics when we talked about that y equals 0 is going to help us find the roots. So we're looking for x squared minus 2x to equal 0. Please make sure that you're writing down all the steps and all of the things that I'm writing down so that later when you look at this you can see the line of thinking and the work along the way. Okay? So I'm going to think about two things that I can multiply, two expressions that will multiply to give me x squared minus 2x. And what I'm going to do is I'm going to do the distributive property but backwards. Okay? So I'm going to think about a factor that is in both of these terms. Well, x squared and negative 2x both have an x in them, so I can think about pulling the x out in front and then writing what's left over, 1x and a minus 2. That way I have x, and if I distribute my x, I would end up with what I started with, an expanded form, which is what I want. Okay? So these expressions are equivalent. It's just that the first one is in expanded form, the second one is in factored form. And my factored form is what's going to help me solve it for equal to 0, because I can think about when this term, x is equal to 0, or when the second term, x minus 2 is equal to 0, which means x would have to equal 2. So that means my two roots for this problem are 0 and 2. Okay, for my next one, I'm going to have 2x squared equal to 5x plus 0. I want it to be equal to 0 on the right-hand side, so I'm going to move everything from the right over here. So I'll get 2x squared minus 5x equals 0. In this case, there's also an x in both terms, so I'm going to take the x out front. There's a 2x left and a 5 left in this equation, which means that either x equals 0 or 2x minus 5 equals 0. So if 2x minus 5 equals 0, I add 5 to each side, I get x equals 2x equals 5, divide by 2, I get x is 5 over 2 or 2.5 as my two answers to this one. All right, now when we have three terms to deal with here, there's no common term in between all three of these to start with. Okay, I've got an x squared, a 10x, and a 25. So what we're going to do is we're going to know that there's going to be two expressions equal to 0, because y equals 0. And I'm going to use my boxes to help me out, because each of these is going to have two terms inside of it. Okay? So I remember that these first two terms have to be x, because when I later go in and FOIL, x times x, first time first, will give me x squared. Okay, and when I fill that in my box, I know that these two terms will be x squared, right? I also know that the last terms here, when I FOIL, have to equal 25. I also know that everything in this trinomial is positive. That means that these are both going to be plus x plus something and x plus something, because they multiply to 25 and they add to this 10x. So it's x plus 5, because that's what's going to give me 5x when I multiply, and 5x here. Remember, to get this term, I'm multiplying 5 by x. To get this term, I'm multiplying 5 by x. It's kind of like lattice, okay? So that means that x plus 5 times x plus 5 equals 0. These are the same term, so that means that I need to figure out when x plus 5 will equal 0, and that's only when x equals negative 5. So this only has one root. Okay? All right. Next one, I need to do the box. Okay? So what I'm going to do is set it up the same way. Start with your x and your x equal to x squared. Okay? I also know that my last term is a negative 42. So to get a negative, I know that I'm going to multiply this term and this term. the other part that you have to remember, is that this term times this term will be this term right here, right? So I know that to get a negative number, one of them is going to be a plus and one of them is going to be a minus. And those two boxes have to add up to give me my total of 11x, because in this last one, these two equal my 10x in my term. The x squared is the first part, and the 5 times 5 gives me my 25. Right? Okay, so in this one, I need to multiply to negative 42. So I need to think about the factors of 42 that will have a difference, because one's negative and one's positive, of 11. And I know that those are going to be 3 times 14. Okay, so I want the 14 to be positive and the 3 to be negative, because I want my difference to be a positive 11. Because this will give me a negative 3x here and a positive 14x here. So this will, when I multiply and add this all out, this is going to end up giving me x squared plus 11x minus 42, which is the expanded form. So the factored form is x minus 3 times x plus 14 equals 0. So I need to solve each of those for equal to 0. So I need to think about when x minus 3 will equal 0. That's when x is 3. And I need to think about when x plus 14 will equal 0. That's when x is negative 14. Okay? All right, 2 more factoring problems and then we're done with this video. I'm going to go through these pretty quickly. And then you're going to try some on your own. You're going to do your very, very best to try to finish these before class. All right, so I always know that I'm going to get x squared by having x in this first one. Okay, I know I'm going to replace y with 0 every time because I'm trying to find the roots, and I know I'm going to get everything to the other side of the 0. So in this case, I'm going to have 0 equals x squared minus 3x minus 10 as my expanded form that I'm trying to solve. Okay, so this case I've got x squared minus 13 plus 42. I know I've got a positive 42 here, but I've got a negative 13. So that means that in this case, I'm going to have 2 negative signs, because 2 negatives will multiply to be a positive 42, but will add to be a negative 13. Minus 6 and minus 7 will give me negative 7x and negative 6x, which added together give me my negative 13. So that means that when I FOIL x minus 6 and x minus 7, I will get expanded form x squared minus 13 plus 42. So x minus 6 and x minus 7 equal to 0 means that x equals positive 6 and x equals positive 7 are my two answers. Over here, I need to multiply to a negative. I know that automatically means I've got a plus and a minus in my factored form. I need to multiply to negative 10 and add to negative 3. I know that the difference needs to be negative 3 because one's positive and one's negative. So I know it's going to be 2 and 5. I know that 5 needs to be going with the subtraction because that'll give me more negative x's, because that'll give me negative 5 and positive 2, which means I'll have an overall negative 3x and then a negative 10 when I multiply it. So if x plus 2 times x minus 5 equals 0, that means x equals negative 2 or x equals positive 5 are my two roots. Try these equations before you come to class. None of them involve actually taking the boxes and factoring. They involve problems such as these, such as the first two problems, okay? So like these two problems, where you just have to find the common term that you can pull out into the front, okay? So go ahead and try those, and we're going to practice a lot more factoring examples when we get to class.